be caution when we do food processing? Can I have two answers? What's a chemical safety? What would be a chemical hazard for food safety? pH. Can people talk about pH as a chemical hazard? Can you explain a little bit more? How can pH become a chemical hazard? I'm really curious. I'm not saying you're wrong, but I'm just curious how pH can be a chemical hazard. Chemical poisoning, okay. Harmful materials, eliminate residue, chemical substance, soap in the food. Okay, those are the answers from people in Taiwan. Okay, actually, for those, I think the most chemical hazard are those that the heavy metals, for example. So when you grow in a field that was contaminated by the heavy metals, or it has been heavily contaminated by a lot of drugs that they use to kill the insect, the chemical that they use to kill insect, it can also be contaminated. The vegetable, fruit and vegetable can also be contaminated as well. So those are the chemicals that were like more concerned about are the heavy metals and the toxic residues that they use to kill the insects or parasites in the field that was intended to protect the crop but also contaminate the crop. Okay, so to make sure for food processing, especially from the manufacturer point of view, that for food safety is always the most fundamental target. It means like it's the fundamental limit that we have to meet for food processing. Okay, we have to make sure that our food are safe from the microbial contaminations, from the chemical contamination. So it doesn't matter how tasty or how pretty your food look like. At least it has to be safe, right? So the safety is always the first aim for all food processing practice. Okay, so after we satisfy the safety need, then now consumer can start asking qualities, higher qualities. I would like to ask you, what would you perceive as a higher quality food? Can I have five answers? For you, what do you think is a good quality food? Nutritious, high nutritional value, tasty, food that is balanced in nutrition, safe, good taste. Okay, from the answer I got here, most people are more concerned about the nutritional value. And some, I think two, are concerned about how does the food taste. Yes, these two are probably most consumer think about. Okay? But for quality, it also include the flavor, also the colors. We don't want the color change into the unwanted colors too much during processing, and also the textures. Okay. So for higher quality food, usually people perceive first more nutrition contain more nutrients. Okay. And the second, it tastes good, or it can have variety of flavors. A third, looks good, right? It looks good, it's nutritious, it tastes good, and it looks good. So tastes good. Third, looks good. And the fourth, the texture. What does texture means? The texture means that it can give us a good mouthfeel. For example, crunchiness. For example, tenderness, juiciness. That's the texture part. Mouthfeel. Okay, so these are the four major quality aspects that most of the consumer care about. So first they ask for safety, and then they ask for higher quality. So safety is a very easy to meet purpose. Okay, we can use a lot of ways. For example, thermal processing, those traditional processing that has been developed long time ago and are well used. But for qualities, how do we get more nutritious food? How do we make food taste good? How do we make it looks good and improve have a good mouthfeel? And we need technologies. That's how technology comes in to give consumers better quality food. Okay? So for first they satisfy their safety, their quality, and now for the third purpose, they want it to be convenient. Convenient for what? Can I have three answers? What's what kind of need is in the area of for a convenient food? Can I have three answers? What's a convenient food? What kind of food do you perceive it as a convenient food? Ready to cook, ready to eat, and fast. Okay, what else? Ready and portable to eat. Okay, and okay, cheap. Cheap is good too, but cheap, yes, sure, of course. Easy to access, easy to digest. Okay, so for when people perceive convenient, we usually think about something really fast, very easy to use, and easy to drink. So how do we what kind of technology allow us to have this type of convenient food? Can you think? Can you think of one very simple way to get this convenience from the food, no, to make food convenient? Freeze dry. Can you can people can the students give me more detail? How can freeze dry make food more convenient? It's an interesting answer actually. But anyway, I would imagine freeze dry is a way to improve the quality, but probably not so much on the convenient. For convenient, usually related to packaging, full package. Okay, so we have those microwave food we can buy from the convenience store, and we have those bottled drink that we can buy from the convenience store, and we also have some of the very interesting food that are packaged to a way that are convenient for people to use. So for the third purpose, the convenience of food, a lot of time are closely related to the packaging of the food. Okay? So here are the three major aims when people talk about food processing, especially from the manufacturer point of view. Here is for the manufacturing. Okay? These are mostly talk about safety first, quality, and the convenience. These are the three basic and for nowadays food processing for manufacturers and manufacturing production plant. Okay, but there are actually more. We have like the processing and especially in the food quality. Today we're talking about minimal processing, so we're more focused on the quality of food. The quality of food, including a safe food, and a reasonable shelf life. These are interrelated because safety usually related to the microbial, micro, and also the chemical, right? We talk about it. So Once we eliminate the microbial contamination and also the chemical contamination, it increases the shelf life of your food. Okay, and then for quality, just like many people mentioned, they want it to be more nutritious. More nutrition meaning this food could be better for your health, and then higher quality. You had good flavor, good texture, good color, just as we talk about. So today we are focused on the quality of food. How do we improve the food quality through minimum processing? What our technology improves the quality of food? Okay, so why they should be processed? Of course, the pathogens, toxin removal, the safety. Okay, and then here we have the quality, right? These are the quality. What I circled is the quality, is in the quality section. This is the safety. Shelf life is also safety. And also here, suits our lifestyle are the convenience. And also this we haven't talked about. Enable transportation is also in the area for the convenience. Why? Why transportation? The process for transportation we can put in a category for convenience. Can people give me two examples how food processing allows better or easier transportation of food? I need two answers. Hello? I need two answers how food processing can make transportation easier. Actually, I really hope I can hear the voice from Japan. Anyone from Japan want to answer the questions? No? Okay, I see some answer from Taiwan. I'll read it out. The size of each packaging, because the larger size of packaging, the more inconvenient it is to transport, or when it includes a specific package, prevent spoilage during transportation, vacuum so that it can be in small size. Salting. Okay, so people always when talk about convenience for transportation, you guys think of size, right? So here for size, they so people say we can use vacuum packaging. Yeah, that's a good answer. You reduce the size, you make it tight, right? Just like you try to pack up the clothes, the winter clothes from your home, you kind of vacuum pack this so it became really small. That's a good idea. But how people actually reduce size? How do manufacturer reduce size? The most effective way is actually dehydration. Okay, dehydration means reduce water removal. So for whatever food materials, including juice, including meat, including fruit and vegetables, they all contain a lot of waters. And once you remove water, you remove most of the weight of the food, and also you reduce a lot of the volume of the food. So if you think about size reduction for easier transportation, you should always think about dehydration first. Okay, size reduction through dehydration, it reduce weight and also reduce the volume of food. It make it easier, more convenient to transport. And vacuum pack has another benefit. Okay, besides reduce size reduction, can anyone think of another benefit for vacuum packaging? It also improved the convenience for transportation. So the vacuum packaging not only reduce size, they also have other purpose, other advantage. Can I have one or two answer for vacuum packaging? Prolong life, reduce oxidation. Yes, that's very good answer. When you vacuum pack a product, that means they remove all the gas, including oxygen, from the packaging, which reduce a lot of chemical reaction that can be promoted by oxidation. For example, lipid oxidation would be stopped, or other oxidative reactions. Okay, so vacuum packaging not only reduce size, it also can improve the shelf life of a food product through preventing the oxidation. And also, so vacuum packaging is a very good way, especially for to improve the quality and also enable transportation because it improve the uh it can actually preserve the full quality as best as you can. And also there are also other packaging that will actually improve the convenience for transportation because they should be more protection from the mechanical damage, from the physical damage, and also it can kind of like separate the inside food environment from the outside, so there will be no outside microbial contaminations. So here we have this transportation. We first think about size, and then we want to think about the quality during transportation. We use packaging to preserve the quality during transportation. And also during transportation, we also use low temperature transport. It can also improve the quality. Okay, so these are few reasons that food are processed, and they all can fit into the three basic need that we just talked about. First, safety. Second, quality. And third, convenience. Okay. All right. So before we get into minimum processing, I want to also make a definition on what's a traditional food processing. What does it mean, tradition? Is tradition means good or tradition means bad? And what is tradition? And can anyone tells me in your mind what would you call a traditional food processing? I want 3 to 4 answers. What's a traditional food processing? All right, I think this tradition can be defined clearly, a little more clear. So what's a like a ancient traditional food processing? So I have some answer like heating without complicated steps, human made without machine, salting without additive. Okay, I think people here are more talking about the so-called the ancient food processing. Okay, like with actually probably no machinery type of technology. Yes, they can be called traditional food process. For example, salt meat, or you can add sugars like the or you can add some vinegar or through fermentation, for example kimchi or the natto. In Japan you have a lot of fermented food. These are some ways that they use to preserve food. How does salt and sugar preserve food? Can I have one answer at least? It's a simple question. I only need one answer. How does salt and sugar preserve food? Why do people add salt and sugar to food in order and they want to preserve it? And then also, of course, this is a food process, just as I defined. As long as you change the original form, you're doing food processing. So why salt and sugar are added to food? For the intention to preserve food. Absorb water, reduce water. Yes, very good. First, you reduce water activity. Reduce water activity, you can do it through salting or I cannot write it here. Sorry. And make it add sugar, right? These will all reduce the water activity because the water from inside of the food will leach out into the environment, which is high salt and high sugar. So reduce water activity. And water activity can also be reduced from by drying, right? So the first way to preserve water activity in a traditional way, easier is the salting and sugar. And with the machine, we can do drying, or without machine, we can use sun dry. So these are all so-called the traditional food processing. The purpose is to preserve food. Okay, the second ways to preserve food is through additives. Additives including the oops, come back. Including the preservative, chemical preservative. Okay, and also the antioxidant. And even salt and sugars are additive. You know that, right? Because it was not originally in the food, you add it to the food, so we can also call salt and sugar an additive. But here we normally, when we think about additive, we think about chemical preservative or the antioxidant that to prevent the oxidation of the food, or some antimicrobial substances. Can anyone give me an example? What's the antimicrobial substances? Yes, antibiotic is one, and we can also have some bacterial things that were produced by other microbes that inhibit the growth of the harmful microorganisms. Yes. So for traditional food processing, normally even your ancestors from long time ago, thousands years ago, they what they do is basically first reduce water activity to make sure that water activity is low so they can preserve the food as long as possible, or they add something, for example some preservative, antioxidant and antimicrobial substances to preserve the food. And as the technology improved, there are some other way, more, or we can call a more severe or more active way to preserve food, instead of just wait there to for the sun to dry up the food, reduce water activity, put salt and sugar or some antioxidants. Anyway, as the technology improve, now we can use temperature control. Temperature control to preserve our food. First, what we can do is increase temperature. What's increasing? How does increased temperature preserve food? For example, again, machine drying, controlled environment, machine, or we can call a controlled environment drying instead of sun dry. Okay, we have the drying machine using hot air, hot and dry air. All right, food concentrations. Here I want to ask one very simple question. What's the difference between food concentration and food dehydration? Which one contain more water? Food concentration or food dehydration? Can anyone answer this question? Yes, very good. Food concentration means you remove partial of the water. Dehydration, the definition of dehydration is to completely remove the water. Food concentration is partially, it can be 10%, 20, 30, but full dehydration usually below 5%. Okay? So they are very different. So for you will use temperature to dry the food, or we can actually heat process the food to kill the micro, right? By increasing the temperature. And the second, we use decreasing the temperature. Can you tell me how decreased temperature can preserve food? Can you give me one or two example? It should be really easy. How the decrease of temperature can actually preserve food? Yes, freezing is one. Any more? And cold storage, like your refrigerator. Okay, freezing and refrigeration. Okay, I want to ask you one but also question. Pasteurization. Yeah, pasteurization is more in the high temperature area. Okay, it's not like decreasing the temperature. Pasteurization usually above 70 degrees Celsius. All right. So freezing, refrigeration, reducing temperature is to also to preserve food. Just for your to improve your knowledge, I just want to know what's the temperature for refrigeration. What's the temperature of your refrigerator? Yes, 4 degrees Celsius. How about freezing? Yes, -18 to -20. That's about the temperature of your freezer. So, why does reducing temperature can preserve food? Can I have one or two answers? Retard microbial growth. Why? Why low temperature retard microbial growth? That's a good answer, but I'm asking you why. Yes, you reduce the reaction rate, you reduce their growth rate, you reduce their physiochemical activities, right? So for every 10 degrees Celsius decrease, the microbial growth will be inhibited by certain percent. Okay, reduce metabolism. Very good answers. Okay, so I guess from your answer, I know that everybody can fully understand what I'm trying to talk about here. For the traditional food processing, without technology, we can use salting sugar and the sun drying, the natural drying to reduce water activities, and we can use additive to preserve food, for example, chemical preservative, antioxidant, antimicrobial substances, and with the technology usually including the temperature control. Also, one improve the increase of temperature through controlled hot air drying or heat processing for pasteurizations or sterilization to inactivate microorganism increase the elevation of temperature, and also in the temperature control on the other side is to reduce the temperature through freezing and refrigeration, trying to reduce the metabolism, trying to reduce the physiochemical reaction rate of your microbial to kind of inhibit their growth. Okay, so here, these are all good stuff. But what is minimal processing? Okay, we talk a lot about the traditional, and one very important concept in the traditional, or nowadays the common way. We don't call it traditional, we can call it a conventional way, or the common way for food processing to preserve food is to use heat. Oh, keep on jumping. Heat is the conventional way for our food processing. They use heat to dry food, they use heat to kill micro, but heat also has a lot of disadvantage to the food quality. With heat we can ensure the safety, of course it killed most of the micro, and also it can give us a lot of flavors of the food, but heat also has a lot of disadvantage. Can anyone give me what's the disadvantage of heat processing? The disadvantage. Protein denaturation, breakdown structure, destroy nutrient, flavor will lost, nutritional will lost. It can damage the quality. Yes. First disadvantage is that it will degrade a lot of heat heat sensitive nutrient. For example, vitamins, minerals. These are They could be some heat sensitive nutrient. For example, they will be oxidated really quickly or degraded really quickly during heat processing. Okay, the second one is the loss of flavor. Why does heat promote the loss of flavor? Why does heat promote loss of flavor? Can anyone tell me? I want one or two guesses. How does heat promote loss of flavor? Because flavors are volatile. Yeah, I give you 50 points. This is a correct answer, but there's other reason too. Okay, so first of all, a lot of flavor they are volatile, just like the student answered. So for volatile compound, usually are those flavor that we can perceive through our nose, right? Those flavor are volatile. Once you heat treat it, then it become gas, and then it was released into the environment and lost from the food. So it reduced the 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 kind of the smell of the food is lost during heat processing. That's why a lot of food, after you heat process, it does not smell as good as the original raw ingredients. That's the reason, because the volatile compound was volatilized and then lost into the environment. Okay, and the other one, how about those flavor that perceived by our mouth? How does those flavor lost? Okay, most of those flavors are small molecules, or even some of them are proteinaceous molecules. And during heat processing, these flavor molecule either degraded through certain chemical reaction because of heat promoted reactions, or these little protein peptide kind of molecules denatured or hydrolyzed, so they lost the flavor compound. Okay, so those perceived by mouth is also lost, and volatile is perceived by nose, right? So heat processing can cause the loss of flavor that perceived by your nose and perceived by your mouth both. Okay, so what's also the problem of heat processing? What would be another disadvantage? Anything more? High energy consumptions. That would be. It is not a incorrect answer, but I won't call it a major disadvantage for heat processing. All right, so let me answer this question for you. So the third one is that the loss of color. Okay, during heat processing, usually there's a lot of browning happens in your food product, right? Some of the color, some of the change color is desirable. For example, in the bakery product, it is desirable to change to brown the product. But most of the time, the color change is not desirable. For example, when you cook vegetable, you don't want it to turn brown. And then when you cook food, sometimes you don't want it to change colors. But heat processing, a lot of time, they cause the change of colors. So here disadvantage is that it destroy nutrient, heat sensitive nutrient, it cause the flavor loss, it cause the discoloration. So heat processing satisfy the need of for the first processing need, which is the safety, but it kind of cause a lot of problem in the second for the second need, which is for the quality of food. Because see, it causes loss of nutrient, and loss of flavor, and loss of color, and even loss of textures. Okay, just imagine after you cook your vegetable, a lot of time it will lose the crunchiness of your fruit and vegetable. So, which means that heat processing is a very old and we use it for a long time, but it has big problem. It causes big problem for our uh food qualities. So now there's newer technology come out. So heat is a thermal processing. So newer technology to solve the problem that heat processing caused. There's new technology called non-thermal processing. Okay. But non-thermal processing, usually those technology are really new and might cost a lot. So they're most of them are still on the stage at the stage for research only. But however, we still want to solve the problem for thermal processing. How do we solve the problem for thermal processing without using a lot of newer technology? That's where we come in. The minimum processing. We process the food minimally just to satisfy the safety. Okay, just to make sure our first need, which is safety, is meat. And then not too much, not overcook it, not over process it to affect the quality of our food. Okay, so minimal process of food is that we minimally process food which minimally influence the quality characteristic of food and process it just enough to ensure the safety, to make sure it has a reasonable shelf life during storage and distribution. That's it. That's all we need. Minimum process means that we only process it so that we don't we only we satisfy the safety and shelf life need, but not overprocessed to interfere with our quality of food product. Okay, minimal process technology are technology that can preserve food and returns their nutritional quality and sensory characteristic by reducing the reliance of heat. These are what I said the non-thermal technology come in. Okay, so to improve the quality, first we reduce the severity of heat processing. Second, we also minimize the reliance of heat using other technology. Okay. We reduce heat the severity, meaning that we can reduce the processing temperature, reduce the processing time. Secondly, we can substitute it with other non-thermal technology. Okay. So minimal processing for fresh cut fruit and vegetable are prepared for consumption by using light combined method such as washing, cutting, grating, and shredding, pulling leaves off. This type of uh, very minimal process without heat. And then after we kind of reduce most of the bacterial load, we use MAP packaging, which is the modified atmosphere packaging. MAP, modified atmosphere packaging. What's a modified atmosphere packaging? Can anyone define it in one simple sentence? What's a modified atmosphere packaging? CO2 and oxygen configuration packaging. Packaging that utilize the airspace in order to preserve food. Well, I guess you might get the idea, but modified atmosphere packaging is that inside the package, if we fill it with air, it should contain at least 20% oxygen, right? But in order, because we all know for fresh fruit and vegetables, oxygen are very important for their respiratory activities. And respiratory activity is one mechanism that causes the degradation or the quality deterioration of your fruit and vegetable. So, in order to reduce the respiration activity, we kind of flush the air with nitrogen, replace the regular air, and reduce the oxygen content inside the package. By reducing the oxygen content in the package, we try to reduce the reactions, for example, the respiratory reaction or the oxidation reaction that might happen in the package. So, with minimal process technologies, modified atmosphere packaging is a good one or a well known one to combine with minimal process technology. Okay, so for here, I hope that when you think about minimal processing, you only have to remember one definition is the processing that we minimally satisfy the need for our safety and also satisfy the reasonable shelf to give a reasonable shelf life while not overcook it or not overdo it to hurt the quality of our food product. Okay, minimal processing is also can satisfy the convenience of our for our consumers. So they they need a quick and convenience product that can have higher nutritional value, retain the natural fresh color, flavor, and textures, and contain fewer additive. Fewer additive means lower or no chemical preservative, right? So minimum processing means that we can still, even though we we don't rely on heat processing as much. We can still give our consumer a safe product that are convenient and also with higher quality. Higher quality means higher nutritional value, higher colors, better colors, better flavors, better textures. And also, when you think about minimum processing, consumer usually perceive fresh food as healthier than the heat treated food. So it also gives the manufacturer a new opportunity to sell those minimal processed food in a premium price. That's an incentive for people to adapt the the idea of minimal process into their production. Otherwise, they can just use the conventional heat processing. That's easy and cheap. Okay, heat processing, because they have long history in the technology, the instrument, the machines are very cheap. So for them to disregard the conventional way, the cheaper, conventional, cheaper way to a new technology, for example, minimal processing or other non thermal technology, the incentive is that the consumer perceive those food as better food than the traditional processed food. So they're willing to pay more for their food. So that's the incentive for manufacturers to adapt new technology to produce better quality of food. Okay. So these are some examples of fruit and vegetable that are minimally processed. Okay, so let's make a comparison for conventional processed food and a non-thermal processed or minimal processed food, less heat treated food. Okay, for the appearance, for heat processed food, the appearance usually change, and for minimal or non-thermal processed food, they usually remain the same. In the taste, the conventional food usually does not taste like a fresh food, at least does not take as a raw food anymore. But for minimal or non-thermal processed food, it usually contains little to no change of the flavor taste. The nutritional value, most nutrients are destroyed because the heat sensitivity. But for the minimal processed food, non-thermal processed food, there usually no change because of the cold process or lower temperature processing. And the shelf life is long for the conventional food. And also here we see the minimal processed food with newer technology, we usually can reach the same shelf life lengths, just like the conventional food. And the safety are the same for both. Okay, so from this chart, we can see that the non-thermal or minimal processed food, we can retain the appearance of your food, the taste, and the nutrition value of your food while still make sure that the food is safe and has a reasonable shelf life. We can all do that with minimal processing and also non-thermal processing. So factors that affect minimal processed food and vegetable and decay with a shelf life are first the need for minimal processing, at least we should meet to inhibit the growth of the microbial growth, which is the safety. Once we meet this need, then others are just unnecessary. Okay, but for other stuff is that we have to also accommodate the physiological change in the fruit vegetable, the respiration or the ethylene production or loss appearance. So the heat processing, we also have to make sure the processing was enough to reduce the respiration rate because of the physiological changes of your food product. And sometimes the biochemical change, for example, surface browning, softening, and loss of texture, is also another factor that we need to consider how to what extent our processing has to go through, and also weight loss and decay. Okay, so the effect of minimum processing on fruit and vegetables. is why we fruit and vegetable are so special. Okay, can anyone tells me compared to other ingredients why fruit and vegetable are so special and they might need minimum process or non-thermal process? Higher water content could be, but it's not the main reason. Any more answers? Why fruit and vegetable are so special? Have full nutrition, they're natural, have source of vitamins. These are all interesting answers, I can say. But what makes them so special is that fruit and vegetable, they continue to live after harvesting. Okay? You pick an apple from the tree doesn't mean the apple die. It's still living. Living means that it's still the respiratory activity of your picked apple still continues, or your vegetables after you harvest it, the respiratory activity still continue. Respiratory continue means that all the physiological activity within the fruit and vegetable continues. They continue to age. Okay, so for example, your apple after you picked it, you put it on the table. It continue to turns sweeter. It continue to become soft. It continue to change colors, right? Your fruit and vegetables still alive after harvesting. That's what makes them so special. And this respiratory or maturation activity actually is also a big factors of quality deteriorations. If they don't live after harvesting, you have no problem. It stay as it is. Okay? But the problem is that it's still alive after it was harvested. That's why it continued to change qualities. And once it aged or matured too much, those food become deteriorated and cannot be eaten anymore. So a lot of times, minimum process for food and vegetable is to delay the aging, delay the maturation of your vegetable and food product. Okay, so these are some factors affecting the respiration rate, is that we want to delay the maturation stage, and also the we mean that we can prolong the time it become overly mature to a way that we cannot consume it anymore. So the respiration rate also depend on the maturation stage, meaning that at what stage you harvest them, and also the storage condition. Storage condition will relate to the temperature. Did you cold store them? Lower temperature reduce the respiration, which also delay the maturations. And also, physical damage occurred during the minimal processing, including the cutting, including the bruising, or um, will cause the disruption of the cellular membrane. For example, cutting. You cut through cutting, you disrupt the cell membrane and release a lot of enzymes. Enzyme also cause the softening of the texture, cause it catalyze a lot of physiochemical activity occur within or on the surface of your fruit and vegetables. So food physical damage during processing is also a factor that will cause the deterioration of your product. So we want to minimize it. Okay. So other quality can increase the respiration rate. Another one is the ethylene. Ethylene. Okay. Ethylene is also another factor that can accelerate the maturation of some climatic product, and also some green leafy vegetable can also be the maturation, the respiration can also be promoted by ethylene. So we can also use technology to control the effect of ethylene. That's what we're gonna talk about later. How do we control ethylene? Okay, the enzymatic browning is also another factors. Enzymatic browning is caused by enzyme that was released by the cell, and the cell, how does it release by the cell, can be caused by the physical damage during the minimal processing or the exposure to oxygen in fruit and vegetables. So once we can minimize the physical damage or their contact to the oxygen, then we can minimize the enzymatic browning. So minimum processing of fruit and vegetable are important for those, especially for those fruit and vegetable that are sell fresh in the food market. Some of the minimum processing are necessary for the fruit and vegetable in order to extend their shelf life or to improve their qualities. Okay? So that will be, so the minimum processing of food mostly sometimes related to non-thermal method. Non-thermal method meaning that no elevation, no temperature increase, or minimum temperature increase, or preserve food with greater retention or no significant detrimental effect on the nutrition and quality of food, and higher consumer appeal and premium prices. So for minimum processing here, we should relate it to non-thermal or less thermal processing, and then better quality preservation and better higher consumer appeal and maybe willing to pay premium price. So minimum process of food are related to this three concept. All right, so for now we already introduced what's a minimum processing, what does that mean to our food, and what does that mean to the fruit and vegetables. For the rest of the class, we're going to talk about some of the newer non-thermal technology. As you can see here, there's a lot of different non-thermal technologies. Actually, one thermal technology that has the longest history is actually the gamma radiation. Through radiation, it's no heat at all, and it's very effective. But however, people are kind of intimidated by radiation. They're kind of scared of radiated food. They think that food that get radiated become radiation will give radiations, right? So even though the gamma radiation has the longest history, they have very low acceptance by the consumer. So, and also it has a high capital cost. So these are not a very welcome way to non-thermal process our food. Okay, even though it's the has the longest history. And there is also modified atmosphere packaging that we mentioned, that we substitute some inert gas with the substitute our oxygen or air with some inert gas, try to reduce the respiratory to prolong the maturation process. And active packaging is that we use, for example, interactive smart packaging, meaning that this package can tell the condition of inside your package by showing the color changing to on the package. And post light and also cold plasma is also non-thermal. Actually, my lab works on cold plasma, but since cold plasma for is mostly still in the research stage and not really used in the industry, so today we're, for the time constraint, we're not going to talk about cold plasma. And today I actually picked four, which is the pulse electric field, the ozone treatment, high pressure treatment, and the last, the hurdle technology, to go into detail to talk about these four. because these four are within all the non-thermal processing method. They are probably the um currently the more well researched, and a lot of them are already used in the food industry for at least this decade. Okay, so we're gonna only talk about this for today's lecture, and I think I'm gonna let you have a break, a 10-minute break, before we come back and talk about post-electric field. Okay, so please come back about at 3:45. All right, student, are you guys back? So if you're back, can you type yes on the screen? Good. I hope that this online class you can still listen clearly, and then I try to generate a lot of interactions. So anyway, as I just mentioned, that for the non-thermal processings, that there's a lot of new technologies or some old technologies, but today we're going to only talk about the pulse electric field, the ozone treatment, the high pressure processing, and the hurdle technology that are currently comparably more used in a full production plant. Okay. Oh, I need. Okay, the first one is the pulse electric field processing. Okay. So pulse electric field we abbreviate it as PEF. Pulse electric field. Okay. The pulse electric field is a method for processing by brief pulses and strong electric field. Here I want to ask the first question for this part of lecture. Why do we use brief pulses? Because we know that the electric field, if we want to process food, we use a very strong electric field. But however, my question is, why do we need to use pulses? Pulses means that very short pulses, for example, less than 1 second. The duration of the pulse is less than 1 second. So for pulse means that we do one and then we stop and then another one and then another one, another one, another one instead of continuously. Why do we do that? Why do we treat our food with electric field pulses instead of a prolonged strong electric field? Can anyone answer the question, or I want you to make a guess, okay? To guess the answer. You might not know the answer, but you can guess. Why do we use brief pulses of a strong electric field? Okay, so the answer are otherwise the food product will be overheated and eventually the tissue structure will be destroyed. Another person said to prevent the heat building up, limit high temperature. These are all three very good and correct answers. Okay, so think about in Chinese, or I don't know if in Japan you also have this ancient saying that if you do bad things, you're gonna be hit by the thunder and killed. Okay, why do you hit by the thunder and killed? The thunder is a strong electric field. Okay, a very, very strong electric field. Once you hit by the thunder, that means you are the food that are processed by a strong electric field. What happened when you hit by the thunder? You get burned. Okay, the heat builds up, and then immediately you're burned to death. You turn like dark. You get burned, right? So you don't want your food to happen to something like that happen to your food. So when you use strong electric field to treat your food, you don't want to treat it in a long period of time with a strong electric field. Instead, you break it into brief pulses. And these pulses, the time of these pulses add together will equal to a long treatment. Okay, but you break into pulses so that the heat will not build up. It gives us some times to reduce the temperature building. Okay, so pulse electric field is that we treat it with our food with strong electric field pulses. Okay, so by doing that, we keep the temperature low. But how even though the temperature are low, the total length of these post treated time are still enough to pasteurize or sterilize food. Okay, so this is the basic definition, is that a pulse electric field is that we use strong but brief pulses of electric field to treat our food so that we can keep our food at a low temperature while we pasteurize or sterilize the food product without any heat. Okay, so this is the definition of pulse electric field. I hope this is clear for you. Clear enough? Good? Okay, let's keep going. All right, so strong pulses, what do we mean by strong? High voltage, okay? We actually have a high intensity electric field are usually for food processing. We use usually 20 to 80 kilovolt per centimeters to food. This is how strong the electric field can goes up to, and this is usually happen to this electric field is usually generated between two electrodes. Okay, that means that within these two electric uh poles, that there are 20 to 80 kilovolt per centimeter of the voltage that happen in the between the two electric uh electrode, I mean. So your food, once they are placed between the electric field, the two electrode, they can be shocked by strong electric pulses. Okay, so these are the intensity of the electric field, and the time of each pulses is usually less than 1 second, usually in microseconds. Okay, so that means that the pulses are very short, and this PEF process is very fast. It can be the food can be shocked maybe 100 to 1,000 times per minute, or within 5 minutes it can be shocked for 100 and 1,000 times, and then which means that the food can be well pasteurized or sterilized within very short time because of the strong electric field and very short pulses. It can be processed 100 to 1,000 or even more times within very short times. Okay, so the energy lost of heating food is minimized. Okay, how does energy lost? Usually lost by heat, by the form of heat, but it doesn't generate heat. So the energy loss of heating is minimized. So which means PF is a very efficient process, which the energy do not loss through generating heat. Okay, so for food quality, the PF is considered superior to traditional heat processing because it eliminates the disadvantage that caused by heat treatment. For example, the loss of the loss of flavor, compound, and also the texture, etc. Can the quality loss that caused by heating is now minimized in PF. Okay, so it also reduce the detrimental change of sensory and physical property of food. So PF, basically here, I want you to remember that the strong electric field, the pulse durations, and then it can quickly process the food in a very short time, and giving the a superior food quality and better sensory and physical properties. Okay, here I want to talk about the electric field. Okay, remember I said the electric field is supplied to the food product. But however, what is used to generate the electric field will also affect the efficiencies to process the food. Okay, so depending on the generator, which means the supplier, the energy input, the supplier of to create this electric field, it will also give different. We will also increase or decrease the efficiency. So for the generator of electric field, usually we can separate in two big category. With one, it gives bipolar type of electric field, and one is the monopolar electric field. Monopolar means all the electric field will will be assigned on one type of polarity, and the other one is constantly changing the polarity. So for electric field, there are charges, positive and negative charges. So for those that at constantly on one side, the the change of the positive and negative side was not so severe. So I want to ask one question for you to take a guess. Is that which type of the power supplier, the monopolar type or the bipolar type, will give a more higher efficiency in the PF processing, and why? Which one is more efficient? Bipolar type. Why? Just random guess, or do you have a reason why? Oh, there's one say monopolar type, bipolar type, because it can act against both gram positive and gram negative bacteria, I think. That's a good guess. Okay, I'll answer a question. Say, like I said, there's positive charge and negative charge in electric field. And within your food, there are also molecules or component that has charges, right? For example, your water molecules. For example, some ions, NaCl, right? So for those electric field that constantly changing the positive and negative direction back and forth, what happened to those ions or dipole dipole molecules? They were constantly moving and changing directions, and by moving and changing directions, they create a stress to the microbial cells that we try to inactivate. Okay, so bipolar is actually the one that are more effective. However, nowadays the supplier we most of the manufacturer used for the P to generate PEF is still the monopolar one, because monopolar the generator is cheaper, which lowers the production cost using this type of processing. But I just want you to know, and I want you to know the reason that the bipolar, even though it is more effective because of changing the positive and negative charge direction, it will cause more stress to the cell than the monopolar one. But it is still not as common because the price are more expensive. But even though they use for the more not so efficient ones, it is still good enough to reach the purpose for the processing. Okay. All right, so here we also has a little comparison chart for the post electric field and the thermal processing. The first is that the post-electric field, because it is non-thermal. Non-thermal here means no heat buildup. It doesn't mean it will be absolutely no temperature elevation. It means that we keep the heat building up at minimum. So because we keep it so low, it is not enough to change the color, flavor, and aroma of the food, whereas the thermal processing will change all these three. And for thermal processing, it is good enough if the temperature is high enough or we treat it long enough, it will kill all the vegetative cell. But it is very difficult for thermal processing to kill the spores. However, on the post-electric field, it can kill all the microbe in the vegetative stage and also its spores. That's another advantage of using post-electric field. Not only it's non-thermal, it is also effective to kill the spores because they utilize a totally different pathway to kill microorganisms than the thermal processing. Okay, so as for the cost, of course, like I said, the initial cost is low for thermal processing because it has a long history. The instruments are very cheap. Because it is easy to buy. A lot of people are selling these type of machines. It's easier or cheaper to obtain those instruments. But however, thermal treatment sometimes, if you want to completely kill the microorganism, you have to input a lot of energy. So the running cost will be high. All right. So as for the post-electric field, the initial cost is high because the instrument cost will be a little bit higher for the PF, but running cost is very low. Can you take a guess why the running cost for PF is low? No, no guessing. Less time needed. Bingo. Yeah, that's right. Because it can treat it very quick. Treat it in very short time. And like I said, there is no energy loss through heat. So it's very efficient, energy efficient. So the running cost is very low. So when you balance up, PF is not that much expensive than the thermal processing. Once you buy the machine, you have to pay a big down payment to buy the machine, but later you cost less to run it. So in the long run, they don't cost too much. Okay. So here less time required, more time required, and better effectiveness to kill the veggie, well not veggie, I mean the microbes, vegetative cells, and also the spores. Okay, here is a model that's to demonstrate how the PF will work. And PF can be a batch processing, can be, or the continuous processing. And here we have a continuous processor. Here we have this PF device that they have the voltage right here. So when the unprocessed liquid food are pumped into the machine and they go through the electrode, it will process right here. Okay, once it's processed, it will be go to the cooling system and then process food. Usually, a PF device is very small. I sometimes I have a video for my students in other lectures, and these devices are quite small. So most of the time, the manufacturer plant doesn't use only single PF device. They have several of them, and they kind of like put it together. So the food are pumped in and then go through a series of PF device. And as they go through this device, they're being processed. Being processed mean they're pasteurized or sterilized. And then before they go to the cooling tank. And the temperature elevation can also be controlled by kind of like adjusting the distance. For example, you can put one here and put one further away, the next one further afar, trying to reduce the build of heat temperature, because if you put it very close like this one, then the temperature will be built up once it processes too overly close of time. Okay, so this is what a sample device of PF look like, and this is the setting of a PF might look like. Okay, so here now we want to go into how PF kill microorganisms without generating heat. What would be the mechanism how this electric field actually kill microbes? Okay, here we want to go through the microbial activation increase with the increasing electric field. Of course, the stronger the electric field, the higher the inactivation rate. Okay, and here has one very important term called critical transmembrane potential, which means that this is the cell membrane. This cell membrane, inside and outside, they should be in balance of their critical membrane. The charge inside of the out and the outside should be balanced. Okay, so once imbalance happen, the integrity of your cell membrane will be disturbed. So by using a strong electric field, we can easily disturb the balance of your cell membrane of the microorganism, and then disturb the physiological activity of your cells, the microbes. And since this technology are related with cell membranes, remember for cell membrane there are two types. We can separate the microorganism to two types. One is the gram positive one, and one is the gram negative one. And here, the gram positive are more resistant to PF than the gram negative, which means that when we treat gram negative microbes, we need more process time than treating the gram negative one. Okay, and also when the cells are bigger, like yeast, compared to smaller microbes, they are more sensitive to the electric field because they have more surface area of the cell membrane to be affected by the electric field. Okay, so here we can summarize a little bit. So here the PF is mainly to disturb work on the cell membrane. So for the gram negative are more resistant than the gram negative one. Gram positive are more resistant to the gram negative one, and the bigger cells are more sorry big. Bigger cells are more sensitive than the smaller cells. Okay, and then here spores, of course, is more resistant to PF. So vegetative cells is more sensitive than the spores. What does these tell us? What do we need to know when using PF for processing food? Okay, can you answer me questions? From looking at my summarize, what do we have to know? What is the key aspect we have to know when treating our food with the PF technology? All right, so what will be the key aspect we need to know when you doing the P? How do we decide that how strong our electric field or how long we need to treat our food? What will be the key aspect we need to learn? Key knowledge we need to know. Anyone want to guess? Electrical sensitivity of the microbiome. That's kind of right. I give you 50%. Anyone else? Characteristic of the micro. I give you 50% too. Okay, so both of you add up will be summarized into one thing is that we need to know what type of microbes are in these food. Okay, first we need to know that what types, what combination of microorganisms are in the food. So by knowing what type of microorganism, then we can kind of tailor our PF treatment to target those micro. So this is very important to you have to know what type of microbe might present in your specific type of food. So that means when you're doing PAF, is no single process can be applied to all the food. All the food is every food is different. Okay, so because there are different microbes in different food, so you have to have the knowledge of what kind of microbes in your food so that you can know the electrical sensitivity of these food and the membrane characteristic of the microbes in order to select a proper treatment parameter for the PF treatment. All right. So for the PF, there's two ways that causing the membrane to break down. The one is the electrical breakdown. Just as I said, this is the cell membrane. Inside and outside, there's charges balanced. Originally, they're really balanced, so they're very healthy, and then can kind of serve as the barrier for inside and outside environment. But as the electric field comes in, it kind of causing an imbalance and kind of squeeze your membrane until it create a lot of micro channels. And as the electric field becomes stronger and stronger and stronger and stronger, the holes become bigger and bigger. What happens when there's holes on the cell membrane? What happens when you have such a big hole on the cell membrane? What happens? Yes, the cellular contents leach out and other stuff that was outside goes in. So your membrane lost the integrity to serve as a barrier. Okay, so which caused the disturb the normal physiological activity of the microbial cells and causing the death of the microbial cell. This is how it kind of killed the microbe. This is called electrical breakdown. Okay, and also, but however, there also one other mechanism called electrical perforation. Electrical perforation happens that when our electric field is not strong enough to create large holes, but however, it kind of poke a lot of little holes on the cell wall. It's very small, but still big enough for water migrations. So see, originally there are a lot of cellular material inside, which means the concentration inside the cell is high. So when there's like little holes that are being created on the cell wall, the water keep coming in from outside. More and more water come in, the cell will be stretched bigger, swell bigger and bigger until popped, break. Okay, it was explode because too much water, it cannot hold it anymore. This is another way that we use a lower electric field and then create little holes on the cell membrane and then kind of disintegrate the membrane and disturb the physiological process. Okay, so two ways: electrical breakdown and electrical perforations. Okay, so the effect of PF on the plant, usually for 126 microseconds at 30 to 45 kilovolts per second, we can kill 50% of the enzyme. And besides using it for the microbial sterilization, there's other ways that we can use PEF. Is that for a plant, we also can use PEF to create a lot of holes on the cell membrane to do what? To increase the extraction rate of the juices. Okay, so when we extract juice, we expect juice come out. And when we create a lot of holes on the cell membrane, that means we increase the migration rate of juice from inside of the cells to the outside. So with pretreatment by the PF, this we can increase up to 10% of the juice extractions. So which means that PEF, besides it can be used by as a sterilization method to for microorganism, we can also use it as a pre-treatment for the juice extraction or other processing purpose. Okay. So the critical factor for the efficiency of PF is that, of course, the electric field intensity, the pulse wise, the wider pulse means that for each pulse they are treated for longer times, and the treatment time and temperature, the pulse wave shape and polarity will also affect the efficiency and effectiveness. And another more importantly, the microbial entity, we need to know what type of the microorganism, the concentration, how much is inside of food to determine for how long and how strong the electric field needs to be applied. And the growth stage, is that the vegetative cell or the spores? And also the treatment media, the pH. pH, if it's like low pH, what's considered a low pH? Can anyone answer? As a low pH. pH 3? Hmm. Usually, we define a food product lower than pH 4.6 as acidic food. Okay? So when we treat low pH food, high pH food, acidic food, then we probably can reduce the severity of our treatment, meaning that our electric field can be less strong and the treatment time can be shorter because less of the micro can survive at acidic environment. Okay, so food with large electrical conductivity will generate smaller peak of the electric field. Therefore, they are not feasible for PF. We mean that once they have good conductivity and the electric field goes through the food, would immediately go through will not stay and generate and cause the inactivation inside the food. So those food that had large electrical conductivity is not suitable for PF treatment. All right, so that's it for the PF, and then we will. Actually, I want to take 5 minutes break because I'm kind of like losing my voice. So let's come back at 4:25. Okay. All right, so are you guys back? Let me know on the message window. Okay, good. All right, let's continue with our lectures. We're gonna now gonna talk about the ozone treatment. And first, I want to talk about what's ozone. Actually, ozone is a type of gas. Okay, what is it? It's a gas that is it's a gas that is highly soluble in water. Okay, by this sentence, what do we know? First, it's a gas. It's very soluble in water. Okay, so what that tells us is ozone can be used in the air and also in the water for processing purpose, right? So which means that not only we can spray into the air, we can also kind of like put it into the water, dissolve it into water, and activate water to be ozone water and use it for treatment. Okay, so ozone is also a natural sanitizer that has a very strong antimicrobial activities. And besides its antimicrobial activity, it is very unstable and quick to react. It is a very strong oxidizer. Very strong oxidizer. Actually, it is probably one of the three strongest oxidizer exists naturally. Naturally means not human made, okay? It's a natural and very strong oxidizer exists naturally. And the oxidative reaction is probably the most effective way to eliminate all kinds of pollutants. Pollutant meaning the chemical contaminations and also the waste chemicals as well as the microbes. Okay, so ozone, I want to summarize is that first it is a gas and it's a soluble gas in water. It can be used in both air and water, and it's a antimicrobial agent, and also it is a anti strong oxidizer. And with these properties, it can you can be used to remove both chemical and microbial hazard that will happen in the food system. So this is a brief introduction of ozone. So ozone advantage is that it's the most powerful, one of the most powerful oxidizer, and it instantly destroy microbes. This we will talk about how and why it can instantly destroy microbes, and eliminate chemical storage means that ozone we don't need to store ozone. Instead, we generate ozone whenever we need to use it, which means we don't need a storage space for ozone. We don't need to store a tank of ozone for uses. We just generate it whenever we need to use it. Okay? It is very environmental friendly and no harmful byproducts. The byproduct is just probably CO2 and maybe water. So ozone does not generate harmful byproduct. It is very environmental friendly, and it can stop the vegetative cell as well as the spores, and it does not affect the product taste. It can be used in air and water. So these are the advantage of ozone. Okay, how do we generate ozone? So for chemical aspect, we all know that oxygen contains of two oxygen ions, right? So it's O2. So when we supplied it with the electrical energy, we kind of break it apart. Sorry, break it into two oxygen molecules. And these two oxygen are very uh insecure and very reactive. So they quickly join the other oxygen molecule and then turn into ozone, which is a three oxygen molecule. And this ozone, because it is charged, it is very reactive. Also, it's reactive and strong oxidizer. Okay, so this is from the chemical point of view. But from the machinery, what we have is that it kind of look like it's kind of like we have two electrode, just like what we see in the PF. We have two electrode. It was supplied with the electrical energy. And then with this two electrode, we generate electric field in between. And in between, we supply oxygen. We let oxygen pass through. When oxygen pass through and the electrical energy supplied to the oxygen inside, and the reaction I just talked about happen. Okay, it breaks apart the oxygen molecule and then causing the combination of one oxygen molecule with the two oxygen molecules and form three oxygen ozone. Okay, this is just very simple chemical reactions, and this machine is quite cheap. Okay, it is not a very expensive machines, and because we need oxygen is known to cause burning or sparks. So we usually for these machines we have a dielectric material in the between, a dielectric material to prevent burning, to prevent fire uh, during the generation of ozone. So how do we generate ozone? We create an electric field that can supply electrical energy strong enough to break apart the oxygen and then causing the formation of ozone. And then this is how we generate ozone. And like I said, we generate ozone whenever we need to use it. We don't pre-generate it and store it somewhere else because it is very reactive. It will immediately turn back into two oxygen. I mean, you know what I mean. So we don't store them. We make them whenever we need them. We make them on site whenever we need them. Okay, how ozone work? This is the fun part. This will answer the question why ozone is so effective to kill microorganisms. The reason is that for a lot of animals or like humans, on the cell membrane, we have an enzyme called antioxidant enzyme. On the cell membrane, we have antioxidant enzyme. So whenever the oxidizer come in, we're not so effective by the oxidant or the oxidizer. However, on the bacteria, virus, fungi, and parasites, on their cell membrane, they have no antioxidant enzyme or a very, very minimal or little to no antioxidant enzyme. So, which means they are vulnerable to oxidizers, especially strong oxidizer will immediately kill them. Why? It causes the burning of their membrane immediately because they have no antioxidant enzyme. And because it's in their gene that they don't have antioxidant enzyme, so they cannot build up the resistance that to the ozone, which means even though you treat them this time for a longer time, there will be no build up resistance, which means that this ozone treatment will always effective toward against the bacteria and virus, fungi, and parasites. Okay. So other oxidants that we probably know are more familiar are the chlorine bleach, which is the familiar smell that you smell whenever you go to the swimming pool. they add chlorine to for the antioxidant for the antimicrobial purpose, try to to make the water kind of clean. So chlorine is a strong oxidizer, just like the ozone. Okay, later we'll have a comparison of chlorine and the ozone. Okay, so microorganisms cannot develop resistance to ozone, and the antioxidant reaction occur when the collision between ozone molecule and a molecule that are susceptible to it. For example, the bacteria, fungi, virus, iron, and the metal ions, and it'll burn holes on the cell wall. And ozone leaves no toxic byproduct. It's very environmental friendly. Okay, and the breakdown product are just water and oxygen. Like I said, this is the byproduct. Very good byproduct. We like it. Water and oxygen. Okay, here we have the pictures of microbial. This is a very smooth and nice microbial cell walls before ozone treatment. Like I said, they have no antioxidant enzyme on top. So whenever this three oxygen ozone come in contact with this membrane, they immediately react and burn little holes. Okay, it cause little holes right here. So from far, we can see that there's little holes on the top. When the holes are rare, it's okay. They can maybe recover it. But when there's high treatment and immediately burn lots of holes, it become cracked. And once the membrane cracked, that means the integrity of membrane is lost, and it can no longer serve as the barrier for the inside environment and outside environment. Okay, this is how it happens, how it reacts on the cell membrane and causing the disintegration of its membrane and causing the disruption of the microbiome. And ozone is a 50% stronger, not only stronger, it also is 3,000 times faster reaction than chlorine. Okay, so like I said, ozone is more effective than chlorine in killing the microorganisms. So it is safest and the most cost effective and chemical free way, environmental friendly, and dealing with the food safety management. Right. And another advantage of the ozone is that the machine of ozone is very easy to produce, and it can be produced in a very small laboratory scale or in a big production plant scale. It is easy to scale up. So this is a very cost effective and easy scale up machine. It's a very convenient technology, we can say. Okay, so ozone, like we said, it can be dissolved into water. So, for over 20 years, the ozone has been successfully used for the sterilization of fruit and vegetable for the minimal processed fruit and vegetable. In this step, we can dissolve the ozone into the water, and here we submerge the fruit and vegetable inside the ozonated water to kill the surface microorganisms by only zero point 0.1 ppm of the ozone in the water. We can kill 95 to 99% of the pathogen or the harmful microorganism on the fruit and vegetable surface, as well as it can quickly degrade the pesticides and also fungicide residue present in the food. Like I said, safety related to the chemical safety and the microbial safety. Ozone washed food product can quickly eliminate these two safety hazards at once, which is very effective. Okay, another one is that ozone can be sprayed as air or as water onto slaughtered chicken. like we said, all the processing, we cut open the animal corp. By cutting it, we kind of expose it to outside environment, which increase the chance for microbial contamination. So by spraying ozone or ozonated water onto the meat product, we can actually quickly eliminate almost 99% of the microorganisms on the surface of the meat, which can greatly increase the shelf life of the product and also the safety of the fresh meat product. And also for fish, it is also very very good because um far in 1929 they found out that the fish water before they are frozen, they can be, if they are washed with ozonated water, they can extend their freshness up to 5 days. And also in the market, if they had also had a method that they dissolve the ozone into water and then make the ozonated water on into ice, and then they put this seafood on the ozonated ice, they can actually extend the freshness up to 6 days. So which means it can also be used not only by cleaning or washing this product, also by putting this product on top of the ozonated ice, it can also extend the shelf life of your the food product. Okay, disinfection of the environment. Like I said, the ozone is a gas. It cannot only be used by after dissolve in the water. It can also spray into the environment to disinfect the microbial or virus that might present in the processing environment. So a concentration slightly before above 0.01 ozone can erase the can kill the spores and also the virus. And also they can use ozone to treat the surface of the eggshell in a dry treatment just by spraying the ozone gas onto the chicken eggs in order to kill all the microbes, because like all the chickens and all the egg product are contaminated with salmonella, and salmonella is a serious health hazard pathogen for humans. So by using ozone with as little as zero point zero 0.01 ppm, we can eliminate over 90% of the salmonella at once. And this is also a very interesting application. It's called deodorization. All the smelling compound, the volatile compound, are in the air. Okay, it can be a good smell, it can be bad smells. So for ozone, when ozone comes in, it can quickly react with this volatile compound. After it was react, our nose can no longer smell the good, desirable or undesirable senses. So this is a good way we can control the volatile compound. Okay, this volatile compound sometimes can be harmful, can be a pollutant, like the paint residue that you use the paint to paint your wall. It smells really bad. The paint residue, the chemical residue, the hydrocarbon or dust pollutant, dirt, and smoke. You can quickly react with these entities and then causing them not to present in the air anymore by quick reaction of the ozone. And also, it can also be used to control the maturation. Like we said that mentioned earlier, ethylene is the important gas that can promote the maturity of the climatic fruit and vegetables. And once the concentration of ethylene is very high, then the it will speed up the maturation or rate of your fruit or respiration rate of your food, and causing the and speed up the degradation or quality deterioration of your food product. So when ozone comes in, ozone will also quickly react with ethylene, exist in the atmosphere, and produce CO2 and water, which eliminate the reaction of ethylene onto the fruit. So effect of ethylene is that without ethylene, the fruit is quickly matured and deteriorated and become uneaten, not able to eat. But with ethylene, the fruit can stay firm and fresh for a longer period of time. So it can be used to control the pollutants in the air and also control the respiration gas, which is the ethylene that causing the deterioration of the fruit and vegetable products. And also in the cold stores, the cold store means that you after you slaughter your meat and then you store it in a big refrigerated environment, a cold room, which is usually around like 4 degrees Celsius, but still they can create some unpleasant smell. By spraying the ozones, we can make the air in the cold room fresher and then create a good environment that without a lot of microbial contaminations. Okay, here we finish the discussion or introduction on the ozone. Then I'm gonna go into the high pressure processing. All right, I want to like, high pressure processing is a non-thermal technology. It does not rely on heat. It is no heat. Okay, it kills the microbe by using pressures. It kind of you use pressure to squeeze the microbe to kill the microbe, not by heat. Okay, so this process uh since it doesn't have heat, so it does not undesirably change the sensory, the physiochemical or nutritional property of the food, and it is currently the most innovative food processing technology accepted by the consumers. So high pressure processing is a method that to use to you can sterilize food through by pressure by using very high pressure, leading to the inactivation of the microorganism and also the enzyme. Enzyme is protein. So by pressurize it, you can actually causing the denaturation of protein, which is also called enzyme denaturation of enzyme, and causing it lost its ability to catalyze a lot of reactions. And this HPP process, we also call it a pascalization process because the unit for pressure is Pascal. So we can they all in the foreign country they also call HPP process a pascalization process. And high pressure processing is a relatively short process. It usually takes less than 20 minutes to complete the sterilization process. Okay, how do we affect how pressure affect on the microorganism is that before the micro are not apply pressure, they live very happy. So and then just like you, we start to have little pressure, but it's okay, we can survive it. Once the pressure is very high, up to 600 megapod, the it can no longer hold the pressure, it gets squeezed and it is not reversible. So even though after that the pressure was removed, they cannot go back to the original state and they're killed by the pressure. Okay, it's just something like uh, three very big elephants standing on the plate, and the plate has a needle, and this and the at the tip of the needle is your micro. So basically, the smaller the microorganism or smaller the living organism, the more pressure it feels because of the it was related to the smaller surface area, the larger pressure it feels. Okay. Okay, so the HPP process can be a batch process or it can be a semi-continuous process, but it cannot be a continuous process just because of the design of the HPP process. By looking at the design, we can see that the HPP process should contain a pressure vessel that can be completely sealed, and it has to have a pressurized fluid that can go around, surround the food product that we need to treat, and we need to have an intensifier to serve as the media to enhance the pressure, and also a pump. Okay, by looking at this one, by looking at this picture, this is a pressurized vessel, and we put our product in, and then we close it. Once we close it, we have a water tank and a pump and continuously supply our water inside. And once the water are full, we use an intensifier. Even though it's full, we continue to squeeze more water inside. This is how we create high pressure, by squeezing more water in when it is already full. This is how we supply pressure. So the pressure was delivered through the pressurized media, which is the water here, to the food, and also to the micro that exists in the food product. And by holding the food product at very high pressure for a certain amount of time, it is sufficient enough to kill the micro. Okay, and this one is a horizontal vessel, and we also have vertical vessels. Vertical vessel is just going in the vertical way, and usually for a laboratory scale, we usually see a vertical vessel just because vertical vessels are usually smaller and space saving. But the a disadvantage of that is that it can hold less of the product. So usually it was very more popular in the laboratory setting, but for the factory, they usually will use a horizontal vessel. Usually it is huge, and it is um more space consuming, but it can hold more product inside. Okay, this is a process of how precious. So once we put our food product in, we need a certain amount of time to build up the pressure, and then once we reach the pressure, we'll have a holding time at this pressure. This time is how we make sure the microorganisms are killed and sterilized. And then once we make sure the process is satisfy our need to ensure the safety, we reduce the pressure to the original state and then let go of the process food out. And during the process, the temperature as well, it will build up, but not very much. So it also remain at this. Once the pressure doesn't increase, it also hold at a constant temperature for the pressure holding time. The application of HPP already used on the fruit and vegetable, meat and fish industry, the dairy industry, are used for shelf life extension, the convenience, or the clean label product, the pathogen elimination, and also the shellfish yield, which we'll talk about later in the next slide. Actually, the later slide. Okay, so fruit and vegetable, the HPP are used for shelf life extension because it kills the micro, inactivate microorganism, and the quality deteriorate enzyme. The microenzyme are killed in the pressurized process. It can preserve better the sensory, the functional, and also the nutrient values. The functional values such as the bioactive in the plant product like polyphenols, etc., antioxidant in the fruit and vegetables, and while improving the food safety. And what type of fruit and vegetable product can be processed? Actually, all different kind of food product. For example, the purees, the sauce, the juice, and chunk of fruit, ready to eat product, even the whole fruit and vegetable can be put in the pressurized vessels. So there's no definite limit of the shape and also the form of the fruit and vegetable product can be used by they can be processed by HPP. And one of the most successful commercial application of HPP is the avocado sauce, guacamole. Avocado sauce. I don't know if you guys have any experience with the avocado. Once you cut open the avocado, then it it kind of oxidizes quickly and turns brown. So it is a product that is very difficult. It is a guacamole. It's a avocado sauce that is very popular in the Western country, but it is very difficult to process because of the quick oxidation nature. But with HPP, the guacamole can be have a very long shelf life, up to 6 weeks. Okay, meat and fish that can also be subject to the HPP. It will not affect the flavor and nutrient. At the same time, inactivate the microorganism and the quality deterioration enzymes. And it can be used on the ham, turkey, ready to eat product. Again, no specific requirement on the form or shape or size of the meat and fish product. As long as it can be put into the machine, it can be processed. Okay, so one of the successful commercial application besides killing microorganism, it was also used as a assisting treatment to increase the meat extraction from shell animal, for example, crabs and lobsters. It can once the I don't know how difficult. I don't know if you have any experience with while eating crabs and lobsters. Is it difficult? Is it easy to remove all the meat from crab and lobster? Can you give me an answer? Easy or difficult? Or to remove all pieces of meat from your crab and lobster, not to waste any. It's very difficult, right? Because kind of stick to the shells. But with the pressure applied onto these shells, shell animals, shell seafood, these meat will immediately separate itself from the shell. So by treating with the pressure HPP pressure, we can actually increase the meat extraction from this shell animal by 45%, which is a very interesting and very efficient assisting process for meat extraction industry. And for dairy industry, we can use it to pasteurize our dairy products and within a shorter time and no heat, so no impact on the sensory, nutritional, and functional properties. And high pressure process works very well with acidic dairy such as yogurt because they only require very minimal of time to inactivate all the microbes in the within these product. Okay, this is a very interesting chart that I want to show you. See, on the x-axis are the pressures. Anyone want to talk? I thought I hear something. I guess that's an accident, right? All right. So when we look at the x-axis, that the pressure at very low pressure, which is 100 megapart, it is sufficient enough to apply onto the shell animals such as lobster and causing the meat to separate from the shells and increase the meat extraction, meat yield during meat extraction. Okay, but different shell animal they require different pressure. For example, here, oh sorry, not 100, actually 300 megapart will be sufficient for the meat to assist the meat extraction. And at around 400 to 600, it is the pressure that we use for the non-thermal pasteurization, and to higher above we use it for sterilization. Okay, so this chart is just to show you how different pressure can be applied to food product for different purpose. Okay, so these are some HPP process that produced by the industries. These are some ham and processed meat, juices, and ready to eat meals, and some sauces like we said, the guacamole, the avocado avocado sauce, the tomato sauce, all different kind of sauce can be used to for HPV treatment. So effect on the food color and flavor usually does not affect the fruit and the vegetable and fruit color and flavor, but it does sometimes will affect the meat color because under pressure the iron in the myoglobin will change from ferric to ferritic, and the globin is denatured, the red color might lost. So sometimes the fresh meat, when we treat it with HPP, we need to be very careful, control the process, not to over process it. But the cooked meat for inside the ready to eat meal is not affected. The cooked meat, the fruit vegetable is slightly modified. Fruit juice is no effect. Flavor is mostly unaffected. Effect on the food texture, unavoidably, after pressure treatment, the texture will be slightly softer than the original one, but not too much affected. And the fat and lipid during HPP process will be crystallized, but once the process is removed, it is reversible back to the original state. So not to worry about the fat and lipid. On the protein and enzymes, they're usually at pressure larger than 200 megapart, and it will cause the irreversible denaturation of protein and enzyme, which means the enzyme activity was eliminated. So, but however, when the pressure is not too high, the protein is not affected. The equipment will look like this. This is the horizontal equipment, which is usually used in a factory. This is the vertical model that I usually see in the laboratory, just for a picture to show you what it looked like. Okay, so for the pressure treatment, usually we don't put a piece of meat into the pressure vessel. Oh, we don't put piece of meat or one strawberry or one apple into the vessel. Usually these products are processed by the HPP after they're packaged. So usually it's an in-package treatment. So what happens is that once it's packaged, so what is the pressure is acting on food and the air inside the package, and also the packaging material itself. So when the pressure was applied on the pre-packaged food, it is acting on these three objects at once. So for HPP, there's some requirement for the packaging material. This packaging material has once they are kind of squeezed by the pressure, of course, but once the pressure is removed, they have to have the ability to reverse back to its original form. And the requirement for that, they can only have less than 18% of change in the packaging form in order to be qualified for high pressure treatment packaging. Okay, so those that has a porous structure package are not suitable for HPP process because those porous structure will be break during the pressurized process. Okay, so these are some requirements on the packaging material for the product. Okay, so the conclusion is that HPP is a consumer acceptable and environmental friendly food product. Is The process is suitable for both solid and liquid, and it can preserve both the flavor and nutrition. It's an environmental friendly process and no byproduct and no emissions. And the packaging, like I said, is a pre-packaged. Usually the food is pre-packaged, so it's an in-package process. So you can actually combine the modified atmosphere packaging with the HPP, which means that when you package your food, you can flush your packaging, the inside environment, with the inert gas to create a modified atmosphere environment, and then subject to HPP. And if the and once the packaging can withstand its bearing property, then the MAP will still remain even after the HPP process. Okay. Okay, so last we're going to talk about the hurdle technology. Hurdle technology is not really a technology, it's just an idea that combining a lot of several, just more than one preservation method. Actually, more than one preservation method to make a product shelf stable while improve the quality and and the safety. And what does that mean? What's the benefit of using several preservation methods instead of one? For example, if we use only heat treatment to kill micro, then we probably have to use a higher temperature and longer time to treat a product in order to reach a safety level. But however, if we combine heat with acid, then we probably can use lower temperature and shorter time to treat our product and reach the same safety level. And what if we use heat and acid and lower the water activity, for example, drying? Then we can further reduce the temperature, shorten the time, and maybe we don't have to be so acid. Acid can also be lower while having a lower water activity. That's my idea of having a hurdle technology, is that it kind of said that each preservation method is a hurdle. So the more hurdle you put in, and each hurdle will require the severity of each hurdle will reduce, which means that when three are combined together, we can reduce the severity of heat, severity of acid, and severity of the drying process. So the benefit of combining several preservation methods is that each individual preservation method can reduce the severity to a level it will not hurt the food quality. Say if the heat is low enough to reach the just the safety level, then it will not hurt the nutritional quality or the sensory quality. Then we combine them all together. We use several of them instead of just one. We can make the final food product quality a lot better than just using one. Okay, so here is that the principle of hurdle technology is that each preservation method is a hurdle, and your micro here is trying to jump over the hurdle. So if it was stopped by any of the hurdle, and the consumer, and what when before it reached the consumer, that means the consumer is safe. So we try to use several hurdles to stop the micro from jumping over. And final goal is to, so when consumer receive this product, there is no micro in there to ensure the safety. Okay, so what kind of so the micro will not jump over. Okay, so there are many hurdles. So for example, the physical hurdles. Oops. So for example, the high temperature, blanching, pasteurization, sterilization, ionic radiation, multiple atmosphere, ultra high pressure. These are all physical hurdles. There are also physiochemical hurdles. For example, ethanol, low pH, redox potential, which is the oxidation reactions, low water activities, oxygen, ozones, salt, smoking, nitrite. These causing certain chemical reaction are called physiochemical hurdles. And there are also microbial hurdles. For example, microbial produced antibiotics, bacterial things, or we can even put in live competitive flora to compete with the pathogenic microorganism to create a a live microbial hurdle. And there are also protective hurdle, competitive, protective culture usually produce antibiotics and bacterial things. Instead of just directly adding this product, we adding the cultures that produce it. Okay, so nowadays more than 60 potential hurdles for the food, which will improve the stability and quality of food. And altogether, the more hurdle we use, altogether we can use them to prevent the jump over of microbes and give the final product, ensure the safety of the final products. Okay, so this is just a cartoon for you to see this microbe trying to jump over each hurdle. And at the last one was stopped by the last hurdle, so the consumer, when he eats it, it's safe. Okay, so this is the basic idea of hurdle technologies to combine different hurdles in order to reach the safety level. So these six are the most important hurdles in food. One is high temperature, which is the heat treatment, low temperature, which is the refrigeration and freezing, and the acidity to change the pH, water activity to uh, achieve by drying, and redox potential is the oxidation, and the chemical preservative. These are the six most important hurdles in food. Okay, here I want to show you some model of the hurdle. The first one is actually the ideal model. Ideal model means that all the hurdle are at the same intensity. So when your micro try to jump over, it get hurt and finally it cannot jump over anymore. This is ideal model. But in reality, none of the hurdles are should have the same intensity. Sometimes the temperature, some are lower, some are higher. So when the micro, which means that higher intensity means that these hurdle might be more effective toward a specific micro, so it has stronger intensity. So these are not so effective, so the micro can easily jump over. These are more effective, so the it takes more difficulties to jump over, and then later a different intensity and less. As long as does not jump over the last one, then it's okay. So here is a model that only a few micros are present, meaning the numbers are very low. The initial numbers is very low. Only little micros are there. So means we only need two hurdles to prevent the final product to contain any micro. How does that achieve? I know it's almost time for class to end. I still want to ask this question. How does few micros, how low initial number can be achieved? No one? Okay, I have to go. Okay, low initial number is achieved by the good manufacture practice, which means a clean processing environment. We can ensure the level of the initial micro to be low, which means that we can eliminate a lot of hurdles, a lot of processing need. Okay, on the other side, if there's too many micro present, then which means it is a very bad environmental control, then the micro original number is very high. No matter how many hurdles we have, it still can jump over the last one and contaminate our food. So that's why a good manufacturing practice to reduce the initial load is so important. Okay, here is a model that this food is very rich in nutrient. It just looked like it give a ladder for the micro to jump. It make it easier to jump over the hurdle. But however, if we can keep the manufacturing practice environmental clean to keep the number as low as possible, we still have the chance to prevent the micro to jump over. Okay. Here is a model that the micro are pre-treated, so it's kind of like set sublethal, is half death, so it has less ability to jump over, so we can need less of the hurdle combination to kill all of them. And this is a model that in a fermented sausage, see, include the preservative, which is the nitrite, the redox potential, the pH, water activity, etc. This is just different hurdle in the fermented sausage to prevent the final contamination. Okay, advantage of hurdle technology is that improve product and microbial safety while not uh while not decreasing both using several hurdle in combination instead of single one to reduce the severity of each one. So the food remains stable, safe, and has still have high good sensory and nutritive values, and applicable to both large and small industries and easy to achieve. So today that will be all for our lectures, and I hope that you guys can clearly understand what I'm talking, and that's it. If I have any questions, you can turn on your microphone or type in the messaging windows. If not, you're free to go.